Welcome to this session. This session will cover operation and maintenance of FSM. I am Parwez Akhtar, Assistant Professor, Manipal University. My field of expertise is environmental hydraulics and computational river mechanics. The broad objective of this session are to understand the importance and role of operations and maintenance for fecal sludge treatment plant, to understand critical operations and maintenance factor to include starting with the design and planning phases, to be able to design an effective monitoring and operations and maintenance plan to ensure treatment performance, and to understand the role of administrative management in the long-term operation of fecal sludge treatment plant. O&M activities are at the interface of the technical, administrative, and institutional framework that enable sustained FSTP function. Here, operation refers to all the activities that are required to ensure that FSTP delivers treatment services as designed. And maintenance means to all the activities that ensure long-term operations of equipment and infrastructure. Proper O&M of FSTPs require a number of crucial tasks. Having skilled workers perform these tasks in a timely manner and in accordance with these practices will maximize the value of the FSTP and ensure its long-term performance. Many FSTP fails following construction regardless of the choice of technology or the quality and robustness of the infrastructure. Lessons learned from these failures are that O&M must be considered as an integral component of the full life cycle cost of a facility, and the ongoing training and capacity building is essential for the operators. In addition, the O&M plan must be incorporated into the design process and receive appropriate review and approval along with the engineering plans. Financial, technical, and managerial inputs are needed to ensure the continuous operation of even the simplest of FSTP systems, and health and safety plans which outline the step-by-step tasks that employees are required to carry out in order to ensure the long-term functioning of the FSTP. While many O&M activities are process-specific, others are common to all facilities, and all O&M plans should therefore include information on the procedure for receiving and offloading of fecal sludge, that is FS, at the FSTP. The operation of specific technologies such that they function as designed. Maintenance programs for plant assets to ensure long-term operations and to minimize breakdowns. The monitoring and reporting procedure for the FSTP, O&M activities, as well as the management of treatment and product. And finally, management of health and safety aspects for protection of the workers and the environment. The organizational structure, distribution of and the management of administrative aspects, and procedure for the on-site storage of FS and the off-site transportation. The O&M must be integrated into the fecal sludge treatment planning process. Incidentally, there are several important factors that need to be considered when planning FSTPs, which will have a direct impact on O&M and monitoring. They encompass both classical engineering aspects of technology integration as well as other issues concerning the institutional management that defines the FSM program. Since O&M aspects are important for the overall long-term success of the program, O&M planning, including the financial provision of funds, should be included in terms of reference that is TOR, for the design of each FSTP. The O&M plan should be reviewed and approved along with engineering designs and specifications, including considerations such as location of the FSTP and its proximity to residential areas, volume and schedule of FS collection, availability of local resources, degree of mechanization of technologies, and final end use or disposal of end product. The location of a FSTP is an important consideration while designing an O&M plan. Facilities located close to residential areas must therefore install preventive controls, all of which have O&M implications. Mosquito control is an important requirement in that case. Other site-specific factors such as soil conditions, groundwater level, and proximity of the FSTP that could result in pollution of water resources or infiltration of groundwater into treatment tanks, directly impacting on the pumping and solid handling equipment, and surface water and flooding risk, which might adversely affect equipment due to scouring or erosion. The volume of FS that is collected and delivered to the treatment plant with operational times of the FSTP will have a significant influence on the O&M cost and requirement. Cultural habits, seasonal variability of waste volumes will impact O&M staffing requirement. Larger systems that operate on a daily basis have very different staffing requirement to those that operate intermittently. Low or high flows that exceeds the design of the treatment system can have a significant impact on the operational efficiency. Hence, the initial planning phase must ensure that is correctly sized to accommodate the expected volume and related fluctuation. Local resource issues that must be considered from the O&M perspective, such as availability of spare parts and tools, consumables such as chemicals for flocculation, reliability of local utilities, including water and power, or local contracting firms to assist with periodic tasks. For example, the powerful vacuum trucks that are needed to empty settling thickening tank require a specific maintenance skill which are often not locally available in mechanical workshop. The degree of mechanization of the FSTP depends on the availability of spare parts, electrical power, and trained operators. Where this is limited, passive technologies such as drying beds and stabilization ponds might be better technology choices. If power availability is intermittent, technologies that utilize manual systems should be chosen over mechanical ones whenever possible. For example, the screen can be removed manually or by a mechanical rake, dried sludge can be transported with a mechanical shovel or with a wheelbarrow, and small composting piles can be mechanically aerated, while compost heaps need to be turned manually. The end use or disposal of the treatment end products has a significant impact on the cost. In a simple FSTP, where sludge is dried for disposal in a landfill or for an end uses such as combustion, both of which don't require high pathogen reduction, less rigorous treatment, and lower O&M costs are involved compared to a system that produces end products for use on food crops that are directly ingested without cooking, such as salad, grains. It is important to take the traffic patterns and the management of truck traffic in and outs of the FSTPs into consideration in order to maximize the efficiency of the receiving and offloading processes, and usually involves managing strict traffic traffic control, and approval of fecal sludge for discharge into the facility. Traffic control is simplified through a well-designed facility layout, access road that allows vehicle to drive through after discharge rather than turn around are not only more efficient but also safer. Offloading and truck parking areas should be leveled, and access road should not have more than a 3% gradient. Similarly, mechanized unloading stations that record the driver's identification and discharge volume can also reduce O&M costs at busy facilities. The waste from different sources can have widely differing characteristics which may impact upon the operations of the FSTP. Residential fecal sludge, such as from pit latrines or septic tanks, is often relatively free of toxic chemicals, whereas restaurant FS may have significant quantities of fats, oil, and grease, especially if grease traps or interceptors are absent or not functioning properly. Similarly, FS from auto repair shops, dry cleaning establishments, hospitals, or other commercial or institutional settings may contain toxic material that are detrimental to the treatment process. FSTP should preferably have parallel treatment trains that can accommodate residential sludge as well as commercial wastes. A manifest form identifying the origin of the load, waste volume, and driver's name is being referred from the Philippines Department of Health is depicted here as an illustration, and just to have an idea of the entries. You can just look out that there is a table which enters the information such as operator, address, type of vehicles, plate number, name of driver, signature, driver license number, name of the other person, and additionally it has been entered approved by authorized representative also. Operators of FSTPs should be trained in the physical inspection of sludge samples. If there is any doubt as to the origin of the loads, samples should be drawn and inspected for color, odor, and presence of grease or oil. Loads that don't conform to standards that have been established for the treatment process should be rejected if segregation is not possible. The O&M plan provides detail on tasks, materials, equipments, tools, sampling, monitoring, and safety procedure, which are necessary to keep the plant running properly, all of which have cost implications that must be carefully considered. Operation and maintenance plans can again be classified as operational procedure and maintenance procedure. FSTP requires clear operational procedure. Therefore, the O&M plans should include an operational manual containing information such as the engineering drawing and FSTP specifications. The manuals, manufacturer's literature and equipment operation guidelines, the responsible persons for each task, the frequency of each activity, the operation procedure and tools required to perform the task, the safety measures required, and the information that is to be monitored and recorded. The treatment technologies also require the control of the aspects such as screening removal, load, quantity and quality wise and frequency, processing such as mixing compost pile, chemical addition for mechanical drying, residence time, extraction, further treatment or disposal of end products, collection and further treatment or disposal of liquid end product, and storage and sale of the end product. And another important aspect needs to be focused upon is monitoring. The monitoring program should be structured in order to provide the operation employees with adequate information to continuously optimize the plant performance and to provide control over the effluent quality. Monitoring may include a range of different methods such as visual or sensory inputs. This include an analysis or measurement. The visual or sensory inputs include visual observations of plant condition such as scum on a treatment lagoon, the color of the sludge or odor emanating from a pump tank. Analysis or measurement at source includes that test strips or kits that can be utilized in the field for measuring pH, dissolved oxygen or temperature, and laboratory testing of samples either on-site or off-site. One important aspect of O&M is asset management also. It is a holistic approach to FSTP maintenance in order to maximize long-term effectiveness of the facility at the lowest possible cost. Cost items that are included in the full life cycle costs of an asset include capital cost of purchase and installation, labor required for operation and maintenance, spare parts for repairs, essential consumables such as grease or chemicals, and replacement cost once the component has reached the end of its useful life. Without an asset inventory, no comparison can be made on the cost of the equipment or the importance of the asset. Frequent maintenance tasks include corrosion control, like scrapping rust, painting metal surface, and repairing corroded concrete. Second one is sludge and coarse solid extracted from the basin and canals. Repacking and exercising valves, that is locating and maintaining fully operational valves. Oiling and greasing mechanical equipment such as pumps, centrifuges, or emptying truck. And housekeeping activities include picking up of refuse and vegetation control. Maintenance procedure can be of two types, namely preventive maintenance and reactive maintenance. Well-planned preventive maintenance program can often minimize reactive interventions to emergent situations which are frequently more costlier and complex. Physical inspections conducted at scheduled intervals are important, where operators look for specific indicators such as cracked wires, broken concrete, and discolored and brittle pipes in order to identify preventive maintenance needs. Monitoring must consider focusing on monitoring of physical, chemical, and microbiological parameters and design of well-outlined analysis manual. Planning and efficient laboratory analysis programs provide the data necessary for making operational decisions, reporting, and findings. If the laboratory analysis reveals biochemical oxygen demand and suspended solid values above the discharge standard, the resident time in the basin can be increased and the treatment performance improved. The chain of study form is the mechanism by which the sampler at the FSTPs communicate with the laboratory with regard to the samples taken and analytical tests requested. It provides a written record of field sampling conditions, special instructions, and a list of who was responsible for the samples at all times. Wherever laboratory analysis is required, an analysis manual shall be provided encompassing the information such as the sampling frequency, site and procedure, for example, grab or composite, and the condition under which these samples should be transported, the storage of the sample, and the chemical. The analysis protocol for each parameter, this should be based on a standardized method if possible. QA and QC plan, that means quality assurance and quality control plan, for sampling and any on-site analytical activities to ensure the accuracy of the analytical data, requirements for split or duplicate sample or travel banks, and information on the calibration and maintenance of the laboratory and on-site equipment, for example, probe for oxygen content and pH evaluation. Another aspects, namely record keeping, is must for O&M of an FSTP to be flawless and efficient. The major component of record keeping are operator's logbook, reception monitoring reports, treatment unit operation sheets, interpretation and communication of technical data. Operators frequently refer to records in order to identify previous fluctuation in the operation of the facility and operational problems that may recur periodically. Review the effectiveness of mitigation measures that may have been used to correct past operating problems and to optimize the O&M procedure. These records should therefore be easily accessible to FSTP operators. Reception reports track the total number of load delivered, the time, date, and driver's name. These records are important to maintain for all fecal sludge treatment plant. A typical record is being presented here for clarity of the concept. The type of records and the length of time for which they will be retained for a particular facility will be determined by the size of the FSTP, regulatory requirements, and the technologies that are used. Records are considered to be an effective tool that can be used by employees to assist in the day-to-day operation of the facility. A summary of the information should be used to optimize the O&M plan as well as in the planning of any expansion to a FSTP or in the design of new FSTPs. The operation logbook is one of the most important record for a FSTP. This logbook provides a means of communication between operators of the plant and a written record of important events. Typical entries include the name of the people on duty, weather conditions, any equipment malfunctions, operating problems, important phone messages, security informations, and action taken in response to unusual circumstances. Another method for record keeping is treatment unit operation sheets that are used to record the quantity of FS loaded into each treatment unit, the operation activities performed, the operational variables, the quantity of end products and waste extracted, and the consumable required, the number of employees required. These sheets therefore provide historical records of the maintenance carried out on each piece of equipment, the failure experienced and the solution implemented, together with the budget and HR involved. Distinction should be made between preventive and reactive maintenance, and recommendations for optimizing the planning process should be made. FSTPs are critical infrastructures, and that's why it must therefore be secured from unauthorized entry and vandalism by fencing off facilities and engaging security employees. Managers of FSTP can also create a culture of security by enacting guidelines such as including security as a topic in employees' meeting and discussions, appointing a plant security officer, that is PSO, or assigning the duties to a responsible employee member, enforcing security policies and procedures consistently and equitably, and providing security training for all employees. In prevailing practice, plant security and safety usually have a specific area of focus such as health and safety, personal protective equipment, infection control, emergency contact procedure, protection against falling and drowning hazards, confined spaces, electrical safety. At last come the effective coordination amongst worker, employees, operators, and other associated stakeholders. An effective vertical communication ensures that the administrative employees understand the constraints and need of the O&M employees and results in rapid acquisition of parts or repairs in order to ensure continuous operation of the FSTP. Horizontal communication between the different FSTPs allows the exchange of experience and therefore assists in the optimization of the procedure. Frequent weekly or monthly meetings should be held in order to facilitate discussion between the operating, monitoring, and administrative employees on the difficulty experienced and possible solution. Apart from various aspects we discussed, the startup period or transition period for FSTPs also invariably has significant influence on overall performance as well as O&M of FSTP. The time required for the startup period may differ depending on the technology used. For example, the acclimatization of macrophytes on planted drying beds or lagoons may require between 3 and 6 months until the nominal treatment efficiency is reached. For some technologies, it is also important to plan the startup period given the seasonal climatic variations, as these influence the operational activities and performance. For example, the time needed for FS to dry at the surface of unplanted drying beds may differ greatly during dry and rainy seasons in arid climate. Thank you.